In problem number 1, we want to simplify this. Now look inside the parentheses, there's a multiplication, and you know, as long as there's a multiplication or division, you can distribute that exponent to each one of those factors. So let's do that. So we're going to get m to the negative 4, p to the negative 4. Now I suppose we could leave it like that. It just depends on how the answer book wants it. Or you could convert those to positive exponents, right? If you have m to a negative 4, move the base down to the bottom, the denominator, but change the sign of the exponent. So you could write this as, well, both of them, m to the positive 4, p to the positive 4. So either one of those is probably going to be acceptable. In number 2, we've got a power raised to a power. So I'm going to multiply the exponent. So I'll get b to the negative 3 times 2. Now that part you can probably do in your head, right? You just do that. So it's b to the negative 6. But I'm going to convert that negative exponent to a positive exponent. So I'll drop the b to the bottom and change the sign of the exponent. Now, I've got a power raised to a power, right? I've got this power, 6 to the negative 2, raised to the negative 1. So I just multiply the exponents. Now, this is the part you do in your head. It's going to be 6 to the negative 2 times negative 1, right? So I get, just do it in your head. So I'll go from here to here. So I get 6 to the positive 2. Well, that's just 36. And in number 4, we've got a multiplication of two powers, right? Two powers, this one and this one, but they have the same base. So as long as they have the same base, you can just add the exponent. So I'm multiplying, so I'm going to add the exponent. So I'm going to get y to the 7 plus negative 4. Now you just do this in your head, right? So you get y to the 3rd. Now I've got x to the negative 8, y to the 5th. I'm multiplying, right, there's an assumed multiplication. I'm multiplying two powers with the same base. So I just add the exponent. So I'm going to get x to the negative 8 plus 5, right, do that in your head. So I get x to the negative 3. But you know, I'm going to convert that, I'm going to get rid of that negative exponent. So I'm going to use the rule where I just drop the base down to the bottom, but change the sign of the exponent. Well, there's only one thing to do here, and that why don't we eliminate that negative exponent? So that x, I'm going to drop down to the denominator and change the sign of the exponent. So the 9 stays on top, the y to the 5th, that's a y, stays on top because the exponent is positive. But this x, negative exponent, drop it down to the bottom. All right, so we're going to get over x to the 9th. All right, now in this number 7, here's what I'm going to do. Before we just do this, I'll show you an easy, fast way to do this, but I want to prove something first. Okay, so if you have like x over y, suppose you have a fraction to a negative power. All right, well, here's what you would do. You have a division, so you can distribute the negative exponent, distribute the exponent to both the top and the bottom. But now you've got negative exponents, right? So here's what I did. I took that negative n, put it here, put it here. Now, when you have a negative exponent, you can eliminate the negative exponent by moving the base but changing the sign of the exponent. So what's going to happen now is that the x will go down, the y will go up. So I end up with this. But yet, when you do that, you change the sign of the exponent. So the y comes up, change the sign from negative n to the positive n, and change the bottom, right? Move that base down, change the sign of the exponent. Right, so what has happened here? Now, I'm going to rewrite this. This is using a rule backwards, but I'm going to write it as y over x to the n. All right, usually we use the rule this way. I'm just using it backwards. Now, all I'm trying to prove here is this. If you have a fraction, x over y, to a negative number, here's what you can do. You just flip the fraction over, but change the sign of the exponent. Now, that's what I have. I've got a fraction, 1 over 9 to the negative 2. So just flip the fraction over, 9 over 1, change the exponent to positive, and now what do we get? Well, 9 over 1 is just 9, so I get 9 squared, I get 81. Now I'm going to use that same rule I used in number 7. I've got a fraction to a negative number. So what I'm going to do is just flip the fraction over, 3 over 4, but change the sign of the exponent. And now I've got a division in here, so I can distribute the exponent to both the top and the bottom. So I get 3 squared over 4 squared, so I get 9 over 16. In 9, we've got a fraction raised to a negative number, so I know what to do here. I'm just going to flip this over and change the sign of the exponent. So I'm going to write this as z squared over x to the 5th, but now make it to the positive 7. And now I've got a fraction raised to a power, so just distribute that 7 to both the top and the bottom. And now I end up with this. I get x to the, no, that's a z, sorry. So I get z to the 2 times 7, that's a times, over x to the 5 times 7. So I end up with z to the 14th over x to the 35th. That's a times. All right, let's eliminate these negative exponents. Now that negative 4, that's not an exponent. That's just negative 4. Here's a negative exponent. Here's a negative exponent. So I'm going to take the a down to the bottom and the b down to the bottom. So I'm going to rewrite this as negative 4 over a to the 5th b to the positive 2. Don't be bringing this 4 down because it's not this, right? I don't have this. I don't have, well, let me get it to right. I don't have 4 to the negative 1. Okay, that's not what I've got. I've just got negative 4. Now in this number 11, we've got a power, but look inside the parentheses. It's all multiplication, right? 4 times. So I'm going to distribute that negative 3 to each one of these factors. So I'll get 4 to the negative 3, x to the, okay, I'll write every step, x to the 4th, let me write it so it's readable, x to the 4th to the negative 3, and then y to the negative 2 to the negative 3. Now, this will be, let's just work inside here. This will give me 4 to the negative 3, x to the, now what do you do with these exponents? You raise the power to a power, you multiply the exponents. So I get x to the negative 12, y to the negative 2 times negative 3 is y to the 6th. Okay, one more step here. Let's get rid of the negative exponents. So I'm going to drop the 4 down to the bottom and the x down to the bottom. The only thing that stays on the top is the y because it's got a positive exponent. So I'm going to have y to the 6th over 4 to the positive 3, x to the positive 12, but we can take care of this one. We'll get y to the 6th over 4 times 4, 16, times 4 again is 64, x to the 12th. In number 12 here, this is just a multiplication. So let's just go through and multiply. I've got two bases that are the same, so I know I'm going to add those exponents. So first of all, 7 times 8, that's 56. Oh, let's get it to right here. So I'll get 56, and then I get z to the, now, same base, common base, so write the common base, add the exponents, negative 2 plus negative 6. I'll write it up here. Negative 2 plus negative 6. So this gives us 56z to the negative 8, but let's eliminate that negative exponent. So I'm going to drop this base down, and I'll write this as 56 over, drop the z down, but change the sign of the exponent.